Hi everyone, in this video I'm going to be going through a couple examples of how to convert from moles using Avogadro's number, and you can be following along on numbers 1 and 2 on the top of page 2. Before we talk about how to set up the math for this, we really have to learn how to type Avogadro's number into our calculator. So it does involve a times 10 with an exponent. And in your calculators, dependent on the one you have, there's a button that means times 10. And then some of your guys' calculators actually has a button that might say times 10 with an up caret. Or maybe times 10 and then it's like a grayed out area. So dependent on your calculator, you just kind of have to adjust and figure out what method works best for you to get you the correct answers. For my calculator, which is a TI-30X, and for the graphing calculators, this method works very well. So you first would enter what is in front of the times 10. So the 6.022, enter that into your calculator. And then you want to find a button that either has an EE on the button, or it might be like off to the side behind the button. So like on my calculator, the button that is above my number 7 has an X with a -1 on it, but in the background of the calculator, it has that capital E, capital E. So in order for me to engage this function, you want to click that second button, which is normally in the upper left-hand corner of your calculator. And then it says I want to use that function that's in the background of the calculator, not the one that's on top of the button. So you first want to start off, now that we've hopefully found that EE button, you want to start off with typing in 6.022 and then click the second button and then click that EE or whatever button it's in the background of. And then at that point, what should be on your calculator is 6.022 and then just a single capital E. Now that capital E means times 10. So you do not have to type times 10. And then afterward, you just enter the exponent of the 10, which is a 23. So sometimes your calculators will give you your answers with this E in there. And you do want to convert that back to writing out times 10 in your answers. But that's what it means, is it means times 10. So when you type it in and use this number, you want to find that EE on your calculator and be sure to be typing the number in properly. The equivalence ratio for the problems that you're going to be practicing is that 1 mole is equal to 6.022 times 10 to the 23rd. Oops, I forgot the unit on that number. So we generally, in chemistry, we will use this for the unit atoms, ions, molecules, or particles. We have converted before, and it's the same exact steps. We just have a new equivalence ratio to use this time. So the thing we want to look at in each of the problems is what we're given and where we are going. So in this problem, it says how many particles are in 0.375 moles of CO2. So our given is 0.375 moles of CO2. Some of you guys like to highlight. Feel free to highlight it. Feel free to circle it or underline it. Do whatever you got to do to recognize this is my given. You also want to note where we're going. So this is asking for particles. Anytime you see the word particles, you want to use 6.022 times 10 to the 23rd. You know you need to use that Avogadro's number. So the first step to converting is writing down your given. So I'm going to write down 0.375 moles. And to shorten up moles, you are welcome to just write MOL, but it's up to you. Some people like to write out the whole thing, and that's fine too. And then we also want to be sure to put our substances in. Now in this unit, we're pretty much sticking with the same substance, but in the next unit, we will be converting to information on a different substance. So it'll be very, very important in the next unit for us to get used to writing the substances here. So then we build our conversion factor because we are converting. And if you recall, whatever unit you start with, you want to cross off. So we're trying to convert to particles, and right now we have a number that's in moles. We want this unit to cross off, and in order for units to cross off, we need to see one in the numerator and the denominator somewhere. So whatever unit you start with, always just chuck it right into the denominator and start there. So we are able now to cross off moles of CO2. Now, where are we going? We're going to particles, and we do have an equivalence ratio that goes from moles to particles of a substance. So we're able to put that into this conversion factor. So up here, I'm going to write down particles of CO2, and I can close my parenthesis. At this point, we can just plug in our numbers. We know that 1 mole of a substance is equal to 6.022 times 10 to the 23rd particles of that substance. So I chuck it into the conversion factor. Moles crosses off. We're left with particles, which is what the question asks for. So at this point, we're able to solve. Now, when you solve using this factor label method or dimensional analysis, you always want to multiply things in the numerator by each other and then divide by the things in the denominator. What's easy about this one is that we only have a 1 in the denominator, and anything divided by 1 is itself. So that makes this calculation a bit easy. So we're going to end up doing 0.375 times 6.022 times 10 to the 23rd. So plug this in your calculator with me. We have 0.375 times 6.022. Find your E button. If you have to hit the second, hit second, and then find the button with the E. And then type your exponents in, 23, and hit equals. Now in my calculator, it says, and I'm going to record it here, 2.25825, and then there's like a little times 1023. Okay, so that's the calculator's answer. Now we always have to go to sig figs when we calculate, and you guys can just go to the significant figures of however many your number that you started with have. So we have 0.375 that has 3 sig figs. So we're going to round this number off at 3 sig figs, and be sure to not forget the exponent at the end there. So our 3 sig figs will be the first 3. So we have 2.25. Now we always have to look after the last significant figure, so at this 8, to determine if this 5 is going to round up or stay the same. Now because the number after the 5 is a 5 or higher, then that 5 rounds up to a 6. So we have 2.26 times 10 to the 23rd, and I believe the unit is particles. So we have to include our particles of CO2, and that's our final answer. Some of you guys in your calculators, you probably got something very similar to this, but instead of having that times 10 there, you had the E and then 23 there. When you record your answer, still take it to the correct number of sig figs, but don't forget to record that times 10 to the 23rd instead of using that E button. Sometimes we forget to record that last part of the answer. Anytime you're going to anything super, super small like atoms, ions, molecules, particles, you will always need an answer that has that times 10 on it. and probably something above times 10 to the 19th or higher, or like in the 20s. All right, so the next one here, it says, if there are 8.62 times 10 to the 19th particles in CO2, how many moles are present? So for this one, we are going from particles of CO2 to moles of CO2. And we started off exactly the same, and then we set up our units so that they can cross off. And if we have an equivalence ratio that can fit into a conversion factor, great. We can just plug in our numbers and then solve. So first step, write down the given. 8.62 times 10 to the 19th particles of CO2. Then we build our conversion factor. And I can see that we're using particles. So we're going to need a really big conversion factor. And the unit that we started with was particles of CO2. And remember, that needs to cross off. So in order for it to cross off, we have to see it in the bottom. So we can put that unit in the bottom there. We have particles of CO2. Anytime we have the word particles, that's always going to equal 1 mole of a substance. So moles goes on the other side of this conversion factor. So we have moles of CO2. And then the equivalence ratio is that 1 mole of a substance equals Avogadro's number, which is 6.022 times 10 to the 23rd. So we can plug our numbers in. 1 is next to the unit mole. And then 6.022 times 10. Now I'm running into each other. Times 10 to the 23rd particles of CO2 is in the denominator. At this point, double check that you've set up your units so that they can cross off. So we have particles in the numerator here, particles in the denominator here. The correct number is with the correct unit. There's a 1 with mole, which is what we need. And then next to particles, we have 6.022 times 10 to the 23rd. At this point, we are able to solve. You multiply all the numerators together, you divide by the denominator. So any number times 1 is itself. So we have 8.62 times 10 to the 19th times 1 equals 8.62 times 10 to the 19th. So plug that in your calculator. 8.62, second E, 19. And then you want to divide, since the 6.022 times 10 to the 23rd is in the denominator. So you divide by the denominator. Okay, D and D. Divide by the denominator. So we have 8.62 second E 19 divided by 6.022 E 23. And then we can equals. Now in my calculator, I got 0.00143142. That's the number that I got in my calculator. Now the number of sig figs in this problem is 3 because of the 8.62. So if you remember from our sig figs unit, you go with the first 3 sig figs, so the 1, the 4, and the 3, and then you look after your last one. In this problem, there's a 1 there, so that 3 is just going to stay the same. So the answer for this one, based off what my calculator gave me, is 0.000143 moles of CO2. And some of your guys' calculators did not give you this decimal. So I'll explain next what it may have looked like for you. So I'm guessing in some calculators it might have said 1.43142 E negative 4. Now, if you guys are recording your answer, you do want to be able to recognize that it is the same answer as this. It's just written in scientific notation. But when you write your answer, we think about it in the same way. So we take a look at the first 3 sig figs, and you take a look at what comes after it and decide if it needs to round up or stay the same. In this case, because it's a 5 or lower, after the 3, it's 1.43, and that 3 just stays the same. So we have 1.43, but then don't forget about the ending part of the number. E to the -4th. It makes it smaller. Now, when you record your answer, please record that E as a times 10, since that's what it actually means, and then it's to the -4th. And then you would write moles of CO2 after it. So either one of those answers work. And you do want to be able to navigate between processing both of these answers, because you could see either one on a test or a quiz. Please let me know. Use the rest of this page as practice, and please let me know any questions that you have, and hopefully this is making sense. Have a wonderful day.